thank you everyone for being here. I'm excited to be here. I traveled here yesterday, first time, and I'm really liking it quite a bit so far. So I'm an assistant professor at the University of Arizona in landscape and architecture in those departments. So it sounds similar to here. And I teach GIS. I teach research methods for our undergraduates, and then also I teach an undergraduate gen ed class called Sustainable Cities and Society. So really happy to be here. And the goal here is hopefully after this talk today, you'll have a much better understanding of how land use planning and landscape architecture and design can contribute to urban water management. They have a role to play, and they can really support each other, but it's not happening right now. So I'm going to be trying to, hopefully you'll have a better idea of the answers to questions of how does the built environment affect water use. I'll talk a lot about how design and planning can influence water consumption. I'm going to be showing you a lot of data from different cities that I've been working with. I'm going to teach a little methodology. I think all of you can do this and replicate this in any other city, so I'll talk about some data sources that you have, and nothing too complicated that I think you could replicate elsewhere. So hopefully you get that out of the talk as well. And then you could then take some of these things and answer questions like, how can we design cities to minimize water pollution and stormwater runoff, the pollution that comes with that. So hopefully you'll get all this out of the talk. And then the big kind of main topic that I want to get into is we have two fields. We have the field of water management. And if we were sitting here in the civil engineering building, a lot of engineers go into this field. But then urban planners and designers and landscape architects go into a different field. And so hopefully the one thing you get out of this talk is that the two fields should come closer together. There doesn't need to be perfect overlap, but they can contribute to each other and they can support each other to better manage water resources. So when I talk about urban water management, I'm talking about all the agencies that are responsible for water quality, water rights, who can use that water, who has an ability to, water supply, so who's pressurizing it and getting it to houses and businesses, and then agencies that are managing wastewater and stormwater. Sometimes it's one agency that does all this. Sometimes it's 5, 10, 15. Water management is very complex, and I love this quote from this study out in California, is that water can pass through the hands of 7 different agencies before it reaches consumers. So just illustrating how complex this is. And if you look at the structure of water management across the U.S., it just adds more complexity. So if we think about all the federal agencies that are responsible for managing water, we have things like the EPA, the USGS, Fish and Wildlife, the Bureau of Reclamation manages all the dams, FEMA steps in when there's flooding. It's a lot of federal agencies who then have to interact with state agencies. So 50 states, there's 50 state departments of water resources, water quality. Different states have programs like water banking authorities. You get into sub-regional or watershed management agencies at that regional level. And then you get into every city, and there's sometimes multiple sewer districts in a single city, multiple water providers. It becomes extremely complex very quickly just within that field of urban water management. And then on top of that complexity, it's very challenging too. So here's a map that I made a few years ago showing drought conditions across most of the West. Every year this kind of changes a little bit, but there's continual drought conditions in the western states, so that's reduced water supplies. And at the same time, all the cities in the West are growing. So here's 10-year growth rates in urbanized areas in 3 states, and you can just see how high this is. So over 10 years, urbanized areas in Arizona grew about 25% population increase. Utah saw almost a 40% increase in population in urban areas, and Nevada saw about a 36% increase. So growing populations, reducing supply in an already arid climate. I was looking at this report. This was from the state of Massachusetts that found that 60% of lakes, streams, rivers, and marine waters in Massachusetts are impaired by pollutants. So this comes from stormwater runoff off of cities, agricultural runoff, sewer and combined sewer overflows. So water management is challenging regardless of whether you're looking at water supply or water pollution. It's very hard. So there's a lot of strategies that can be used that water managers can just enact to try to better manage water resources. So implementing green infrastructure or rain gardens. I saw a good one out here walking into this building. So you can implement some of those design choices. There's better information for customers. So we can provide live how much water you're using. Can we influence customers' behavior if you give them more information? We can bring on more new water supply sources with things like desalination plants. We can recycle our wastewater. These are all things water managers can just enact right away. What I want to kind of focus on, and why I think urban planning and design and then landscape architecture as well have a role to play, is it increases the number of strategies that are available to manage water resources. So if urban planners can contribute and designers can contribute to water management, it expands the suite of tools we have available. So we can build homes and businesses that are more water efficient. So if you can build them so efficient, they'll just use less regardless of the people inside of their behaviors. We can manage flood risks by directing development away from flood-prone areas, reducing costs of having to then rebuild infrastructure or housing. We can protect water supply resources from urban development. We can protect rivers. We can protect watersheds. And implement stormwater controls during construction. So when we're building new development, we can try to keep that water on site rather than contributing to stormwater flooding in the area. So by combining these two fields, it expands the options. That's really kind of the key thing. But this is a recipe for failure because water management agencies have the responsibility to manage water resources, but have no jurisdiction or authority to make some key changes to how cities develop that do end up influencing water resources. So if you're working for State Department of Water Resources or the public utility in any city, you've got no authority over things like subdivision codes, zoning in the region. You can't implement form-based codes to shape development. Have no control over municipal ordinances that can impact how landscaping takes place. And then also you don't get a lot of say over building codes. So if you have responsibility for managing something but you have no ability to change it, it's a recipe for failure. Hence, the need to bring together these two fields, because the fields of urban planning, design, and landscape architecture can interface with things like city councils, developers, to really kind of shape the built environment to be more supportive of water resources. So that's the big picture. Now I kind of want to get into how can we design cities so that they're more water efficient, and think about some of these kind of tools, and I'm going to show you a bunch of data here. So the way we design and build cities influences how we use and dispose of water. And a lot of it's intuitive. If you look at the household scale, if you have a large house with a lot of bathrooms, a large lawn, and a swimming pool, it's going to use more water than a house with none of those, or just one bathroom. So that's all intuitive. But the data also shows that design characteristics at the neighborhood scale have an influence on water consumption. So things like urban density, land use mix, these have an influence on water consumption in addition to the characteristics at the household scale. And then we see those, some of those smaller scales, the cumulative effects scale up to the city level, where some cities use far more than others. You look at cities here in the U.S., they tend to use more water than European cities. So there's city-scale design elements that influence water consumption. So let's look at some actual data here. What I'm showing you is 80,000 properties in Salt Lake City, Utah. And what I'm showing is the volume of water that each of those buildings consume. So don't picture these as skyscrapers. The taller the bar, the more water is being consumed. So it's kind of showing in 3D. And then I've color-coded it. So yellow is all the residential properties in this city. Red are commercial properties. Green are the parks. Blues are kind of schools, public buildings like that. And I'm going to start an animation here. We're going to go through 2 years of water consumption data. And in Salt Lake City, it's snowy in the winter, it's hot in the summer, and I want you to just see that water consumption in the summer months really greatly increases. So you'll just see the months ticking away at the top here. And when we get into the summer months, you kind of see this increase of water consumption across all properties in the city. We're going into the second year. Water use remains high in some properties. And then we go into the second summer, and you see again that seasonal increase of water consumption across all properties. So just by looking at how a city consumes water over 2 years, you can see some patterns. There's the clear seasonal effect of outdoor irrigation. Most of the water that you see being used is to irrigate lawns in this city. But you also see that some properties just use a lot of water, more than anyone else, year-round. So kind of just see some insights from that. Here it's very obvious that when precipitation is lowest, water consumption is the highest. And so this is a challenge for managing water in any city that exhibits this pattern. So this is an arid climate, but you see this in other cities where water consumption is just higher in the summer because people are watering their lawns. Here's some water data from Salt Lake City by land use type. And this is, it reveals a couple of interesting insights here. First, most of the water in this whole city is going to support single-family residential development. So no single-family residential property uses all that much water. It's the cumulative effect of having so many of them. So in this city, there's 65,000 single-family residential properties. They use the most amount of water cumulatively. Some of the high-use accounts are industrial accounts, where one was using almost 600 million gallons a year. Any guesses on what that could be? What industrial account in a city might use that much? Yeah, in the back. Oh, good guess. Absolutely. I've seen in Phoenix there's a milk bottling company that uses about that, but no, not in this case. Yeah. Restaurant? Not a restaurant. Yeah. Waste management? No, that's not a bad guess, though. That would be high. In this case, this is an oil refinery in the city. So you know that in order to process crude oil, you need to use a lot of water, you need to use a lot of energy and a lot of pressure. So the oil refinery uses a lot. And then what I've seen in a couple different cities, that school that uses so much, that's the university. So in a lot of cities, universities tend to be one of the top consumers. So to try to get a sense of this scale, I took the 3 top water-consuming properties and calculated the volume of water that was consumed, and it came to about 100 million cubic feet of water. And then to try to visualize that, I tried to think, what's a comparable volume? And I figured out that the volume of the pyramid at Giza, if it was hollow, is less. You could fill 3 buildings in Salt Lake City could fill the pyramid at Giza with water over 1 year, and then enough to turn it into a fountain. So to give you an idea, just 3 properties use an immense amount of water. So this could be good targeting for water conservation if you need to do it quickly. Most of the water use is from single families, so you want to take long-term approaches to reduce that water consumption, but if you needed to save water really quickly, you could target these 3 buildings. So the next set of data I want to show you from a study that I was able to work on with colleagues at Portland State University and ASU. And what we were doing is we were looking at, independently, we were working on different cities. And so we had each written and published papers on different cities, and we just got a hold of each other. And this was great. I just sent an email, asked him if he wanted to collaborate, and I got 2 wonderful colleagues here. So as you guys are doing your own work and research, never feel bad about sending an email to someone whose paper you're reading. This paid off hugely for me, so you can always do that. What we were able to do then is we were able to take data that we had collected from a couple individual cities and combine them into one large data set. We then tried to answer the question, how does the built environment affect urban water use? Because if we know the answer to that question, we can help develop municipal ordinances that can shape development to bring down water consumption. It'll be clear empirical evidence that can help link up land use planning and urban water management. Say, here's why you guys need to work together. And then ideally, we can help achieve water savings through design and planning. So in this study, we were able to partner with the public utilities in Salt Lake City, Phoenix, Austin, Texas, and Portland, Oregon, and get water consumption data. And that's actually really hard data to get. It's not always public. I've had to, first time in my life I've ever had to sign non-disclosure agreements was to work with cities to get their public utility data. So engaged in those agreements, and we've got these great data sets now. So with these 4 cities, as you can see in that map, they really fall across a gradient of different climates. So this was a good selection because if we can find common trends in each of these cities, it's likely to be true in other cities. And it's not just dependent on things like climate. So the data that we were able to get, we started with monthly water consumption, and that was a little bit of what I was showing you with that animation of the 3D city. Then we're able to measure vegetation across the whole city using the National Agricultural Inventory Program, and I'm going to talk more about that in a minute. And then use the tax assessors. So every county in the U.S. has a tax assessors there. They have great records because they're taxing. So you can have really good information on things like when the property was built, the size of the property, how many bedrooms, how many bathrooms, get some information about the properties themselves. Then we're able to collect things at the neighborhood scale, including population, housing density, family size, income, some of these kind of key control variables that would influence water consumption. And then we also controlled for precipitation across all the different cities. We did a type of analysis called log-log linear regressions, but basically this is a linear regression. What independent variables predict a dependent variable, but we take the natural log of all those variables in order to calculate elasticities. And because each coefficient is an elasticity, which is great because it's very intuitive to report those findings. Because elasticities can be represented as a percent change in one variable results in a percent change in another variable. So this is great for translating into policies and design changes. So our findings could be like a 1% increase in density is associated with a blank percentage change in water consumption. Kind of give direction of effect and strength of effect to policies, even if we're not hitting exact perfect numbers. So briefly, here's just a couple of the key findings from this analysis. One, I think it's pretty interesting. So we modeled each city one at a time, and then we combined all the data sets and measured them. One of the first really interesting things I saw was that the percentage of variance that we were able to explain with just 5 measures of the built environment was very high. In 2 cities, we were able to estimate over 70% of all the variation in water consumption with just 5 variables of the built environment. So if you know those 5 variables, lot size, total assessed value, housing age, vegetated surface, and housing density, you could predict with some accuracy how much water is going to be consumed. It's really good evidence that the way we're designing and building these cities influences water consumption. It wasn't strong in all the cities, but you can kind of see when we combine them, we're still explaining over 50% of the variation. This is good evidence that these matter a lot in determining how much a city uses. So the consistent findings were urban density is associated with lower water use. This was the highest in Phoenix, which is a large, sprawling city. So increases in density there would be likely to achieve water savings just through design and permitting and planning. It was significant in all cities except Salt Lake City, but I think that's a sample size issue. We had a smaller sample for that city. Another clear finding was vegetated cover is clearly associated with higher water use. It's very intuitive, but the data clearly backs that up. Where we found a 1% increase in vegetated cover is increased with a 0.4% increase in summer water use. So more vegetation, more water. Effect was greatest in Salt Lake City and had the least influence in Portland, but was significant in all cities. So to kind of take those findings and then think about them in a planning and design context, here's 2 diagrams. The first one's showing what these changes would look like on one property. So that image at the top is showing design changes on a single family residential property. In red, I'm highlighting what a 10% lot size reduction would look like. So not a lot, but you could save about estimated 600, 700 gallons per year just from having a smaller property. In orange, I'm illustrating a 10% vegetated cover reduction, and then you start getting up to 3,000, 4,000 gallons would be saved a year, and you still have it not that different. So those are very small volumes in the context of citywide water consumption. But you start getting larger savings if you extrapolate those findings into what future development might look like. So if you were to plan and design and permit these buildings with these design changes, and let's say the next 5,000 single-family residential properties were built this way, you start saving millions and millions of gallons of water each year. So good evidence that design and planning can help conserve water resources in cities. And then finally, this is really good empirical evidence that the built environment influences water use. Up to 74% of water consumption was explained with just these variables, and it really supports that the way we build and design cities influences how we use water. So it's good evidence for urban planners and designers. They have a role to play. So the question is, can we change the permitting and design of cities? And then what would be the most effective changes to target through design and planning? So if we can't do everything, what would be the most important? And the data is pretty clear there. It's how do we change landscaping in cities? Because that's where most of the water is going. You saw those huge seasonal swings in water consumption when we were looking at annual water consumption. And the good news, urban planners and designers can very much change how landscaping affects water consumption. This image here, you can see it on the right. Those 2 houses were 2 of the top single-family residential properties that used the most amount of water in that city. So you can see it's a giant house, a huge lawn. I think one has a swimming pool and a fountain. It's intuitive, but you can have effects even on properties that don't look like this. So the next part of the talk, I really want to talk about how you can measure vegetation and water consumption in cities. And this will be this is a methodology all of you can use. I'm going to be showing you public data sets and pretty simple analysis techniques that with the right software, you can go out and measure vegetation in any city and then work with those cities to see if there's any way that you could look at the water consumption data. So hopefully you'll be able to learn how to measure vegetation in cities after this. So I think it's important to recognize that I showed you in Salt Lake City and in Austin and in Portland, most cities, most of the water is going towards outdoor irrigation. If there's agriculture in the city, that's a high use. The oil refineries are high use. If you have a nuclear power plant, that's high water use. But in general, a lot of the water is going to support lawns on single-family residential properties. So if you see development looking like this, you can safely assume that most of the water is going towards outdoor irrigation. This is really interesting, and you can do this at home to double-check me. If you just got in a Google image search and you typed in American Dream House, here's the search results that you get. What's a common theme you see in all these images? There's a lawn. Yeah, so it's a cultural thing. It's very much, if you're going to build a property and have a house, a nice green lawn is very much a part of that. And so it's very much a cultural drive to have nice green lawns. I found this study that estimates that lawn and turf grass is the most commonly grown crop in the U.S., where they tried to estimate the total acreage of lawn across the U.S. and then compared it to our kind of top crops like corn, soybeans, and other orchards. And they found that by far there is more acres of lawn than any of these agricultural crops. So then they extrapolated the water consumption that would be needed, and there's more water that's going towards irrigating lawns than agricultural products. We could probably pick this analysis apart a little bit because most water goes to agriculture. But it just illustrates how much lawn exists and how much water it consumes. So here's how you go out and you can measure vegetation in any urban area. We have access to a publicly available data set called the National Agricultural Inventory Program. I'm putting the URL here where you can get this data. But this is publicly available and for the entire United States. And they collect it every 5 years. So they just released the 2020 data. It's aerial imagery that's captured in airplanes at 1 meter resolution. And the data that they're collecting is called multispectral imagery. What I'm showing you here, this is the Phoenix metropolitan area. It is 73 miles by 62 miles. This isn't a screen grab off of Google Earth or anything. This is a 125 gig image file, where every pixel is at 1 meter resolution and contains information about what wavelengths of light have been reflected off the ground. So that's the only hard part about this. You can do this very easily for small areas. To step it up, my research assistant and I had to do 240 downloads and then stitch them together. So that was a little hard, but you can do this at smaller scales quite easily. And so multispectral imagery, if you picture this as an image, every pixel on your screen contains information about which wavelengths of light have been reflected. And we know that healthy vegetation strongly reflects green light. That's why we can see plants are green. But what we can't see with our eyes is the near-infrared band. And healthy vegetation strongly reflects the near-infrared wavelengths of light. And that's what this data can pick up so well. So you can see that this image on the right is kind of what the data looks like. So it just looks like an aerial picture. But every pixel contains these wavelengths. And so in this next image, I've had the software highlight the near-infrared bands with this artificial bright green. And so immediately you can see how well this data works. You can see obviously the golf course was picked up. But you can see the trees in people's properties. You can see which ones have turf grass in between them. It's accurate to 1 meter, and you can really clearly see this. You can even see which parts of the lawn are well watered and which ones are not. So with this data, you can then classify land cover, where you can say this is either vegetated or it's not, and you can then assign that to properties. So what I'm illustrating here in these kind of pink outlines, if you can see, is a parcel map. So the individual properties across this city. So now all of a sudden with this data and the parcel maps, I can say this property has 50% vegetation on it, it has 20%, it has 5%. You can then relate those proportions to water consumption. You can then take it one step further and do entire land use classification maps for regions with this data. So this is showing, there's this great data source that was also made publicly available that is building footprints for the entire U.S. So you can go out and for any city, you know where all the building footprints are. And so if you combine that with this data, you can do land use classification maps like this that show buildings, vegetation, bare ground, impervious surface, and then standing water. And with this analysis, it's not perfect, but it was about 94% accurate for 1 meter. So once you build these data sets, you can then kind of just get insights into all sorts of water management. Knowing how much impervious surface is critical for stormwater management and trying to estimate how much stormwater is coming off of a site, what volume of water you need to manage, you can kind of arrive at some of those calculations with this data and approach. So thinking back to that large image of the Phoenix metropolitan area, I'm then able to summarize land cover by land use type. So this is some interesting insights. Across the whole region, and this is desert, mind you, there's 134,000 acres of vegetation across this desert landscape. Most of it, and you'll see this theme or come up again, most of the green grass and vegetation in this desert area is on single-family residential properties. So this is lawns, this is people's backyards and front yards where most of the vegetation is. And if you look at the bottom of this list, you see golf courses, cemeteries, agricultural fields, which are larger. There's far less vegetation on these land use types. And again, it's because a lot of these cities develop mostly single-family residential properties. So most of the vegetation is on single-family residential properties, and most of the water is consumed in single-family residential properties. So in this county, there's 8 times more residential vegetation grown than all agricultural crops. So again, supporting that, what is the most commonly grown crop in the U.S.? Pretty good odds, it's turf grass. And then, looking at the water consumption data in this city, most of the water is consumed in this city supports single-family residential development. So, then this begs the question, is this the best use of a critical resource in an arid city, is to support single-family residential development turf grass? So, if we think the answer is no, and I think we could argue that pretty strongly, then it comes, what can urban planners and what can designers and what can landscape architects do? And so from a real planning perspective, there are some powerful tools to reduce vegetation on properties. These could be subdivision codes that regulate how subdivisions are developed, zoning codes which you can apply to large areas of a city. You can use specific form-based codes to say what is the actual design and kind of what materials will be used in specific developments. And then you can use municipal ordinances, so planners and designers working with city councils to pass new laws that apply in the city to regulate vegetation on properties. So while this is not commonly implemented, there are some good examples of cities doing this. And so I want to let you know about 2 good ones. One is in Tucson. So they have the xeriscape and landscape and screening regulations. So this is a city ordinance that was passed. It was passed by a collaboration between the Water Management Agency there, one of the public utilities, the city council, and then the planners in the city. They passed it a long time ago. They passed it in 1991, and it applies to all new development in the city. So you'll see a lot of properties in Tucson look like this. They have a big native desert tree, and then a lot of desert vegetation. And so the language of the law requires the use of drought-tolerant plants. And so what's great, too, and here's the role of the landscape architects, is they provide a list of drought-tolerant plants that are suitable for desert landscaping that also look good, and then you get your flowers and have a nice design to the property while still conserving water. What this law limits is turf grass. You only get 5% of your property to be turf grass, and they call those oases areas. So if people want a small area of turf grass, if they have little kids that they want to not have them play in the rocks, that's an option. And it also requires canopy trees, and this has energy implications as well. So good example of a local law crafted with water conservation in mind that it's extremely effective. When I moved to Tucson and started to try to work with Tucson Water, the public utility, I met with their water conservation director, and I was explaining some ideas of what we could do, and she said, you know, we're not interested in conservation anymore. We've achieved the lowest per capita water use in the U.S., and we don't want to force people to save anymore. So these design changes can be more powerful than changes in customer behavior. So they weren't even really interested in that. Las Vegas, another arid city, has implemented one of these. Their Las Vegas landscaping code limits turf to 25 to 50% turf on an entire residential property. So it's a little bit more generous. But they prohibit turf in most public facilities. Commercial properties are limited at 25% turf grass. And this occurs when new construction happens. Or if a property needs to come in compliance, if they add in sort of an accessory dwelling unit, or if they make any renovations, they have to come into compliance with this law. The law also specifies the type of irrigation that's going to be used, because that's if you plant a low-watered landscape, but then use inappropriate irrigation, you might end up still using a lot of water. And what's so cool about Las Vegas is they recycle 100% of their indoor water. So anytime if you ever go to Las Vegas and water goes down the drain, that's going to get treated and returned to Lake Mead, which is their source of water. So they treat their wastewater, goes back into their source, and then that's the water that you're drinking in Las Vegas. So their top concern is how do you conserve outdoor water use? Because if you water plants, there's evapotranspiration, and that water leaves the system. This is one strategy that they've implemented. But again, and I'm going to keep hitting on this, water management agencies can't do this alone. They don't have the jurisdiction, they don't have the authority. Again, it's a recipe for failure unless they can coordinate with the land use planning agencies in the city. And so that's what I want to talk about for the last part of this little lecture here, is how do we get these different agencies that are structurally separated through education and policy and history, how do we get them working together so we can implement these strategies? And by no means am I the first person to call for this. So there's been well-known calls for better integration through, it falls under different names sometimes. So right now the popular one is called One Water. You might see this every once in a while. It's really trying to treat all stages of the water cycle as a resource. So wastewater, like what Daryl was saying, we don't want to see it as waste. It's actually something we can use, and we can treat it. We can use it for landscaping. There's in civil engineering and a lot of public utilities, it's called integrated water resource management. And they really stress that the changes are socio-political. We need to figure out how these agencies are working together. It's not technological advances that we need. We need to figure out how these agencies should better work together. And then in Australia, it's called water-sensitive urban design, where we try to build and design cities that are more water efficient. So my research just kind of seeks to build upon these existing calls and support them. So the final bit of data and research that I want to show you is the results of a couple national questionnaires that I've done. So I was able to partner with the American Planning Association and the Water Research Foundation to administer questionnaires that ask practicing planners and water managers, how much do you work together? Is it enough? What kind of things are you doing? What would be some strategies to break down these silos? The goal was to target all practicing urban planners in the country, so the American Planning Association, and then trying to target the water management practitioners in public utilities. So the Water Research Foundation is an organization that public utilities subscribe to and get research products, and it's like a professional organization. So did 2 online surveys through their emailing lists, and we were able to get over 1,000 questionnaires back from practitioners, and that's where these next set of data come from. Recently was also invited to help out with a survey in Colorado, where we surveyed 23 counties, 71 cities, and 7 special districts in Colorado. Similar questionnaires, similar questions. I'll pull in some of that data as well. So the big picture, in the APA survey, we asked the planners, do you think you're working enough with water management? And so we gave them a couple of options, yes, not enough, or I don't know. Any guess on where the majority landed? How do you think the planners responded to, do you think your role in water management is enough? Any guesses? Yeah?
It wasn't enough.
Yeah, great. 76% of all the respondents said they were not involved enough with water management. So that was the planners. What do you think the water managers thought? Being good engineers, they were more confident in their work, but 58% did not think land use planners were involved enough in water management. So the majority of practicing water managers that we were able to sample did not think planners were involved enough. Then you can see, start comparing these surveys, and the question in the Colorado survey was a little bit different, but we found that most planners thought they were only somewhat involved in water management, so not enough. That's kind of the key finding across all of these. The practitioners report that integration is occurring, but not at the extent that they would want. So the planners, 78% of practicing planners indicated that water was among the top priorities that they should be working on. So again, like Daryl's quick poll at the beginning, how many of you think water is important? 78% of practicing planners thought it was important. However, the majority of those planners disagreed with the statement, planners work sufficiently with other water management professionals. So they know it's important, but it's not happening. This was interesting. You see this little infographic here. That top graph is showing the percent of respondents whose job they spend 100% of their time working on water. It was only the engineers that are spending all their time in water management. And you look at what the planners are doing, the planners are only spending 0 to 10% of their job, if any, looking at water resources. There's a lot of other planning issues. You need to think about housing. It's a wide field. So it makes sense, but they're reporting that they're not spending a lot of time on water. So we asked these different audiences, where should there be coordination? So the water resource managers said the top priority is managing floods or storms. We need to be avoiding situations like this. We need to preserve or restore watersheds, wetlands, or other features. There's concern over development occurring that would impact our water supplies. There needs to be long-term planning for water supply and wastewater service capacity. What happens when you just endlessly permit new development in a city? Will there always be enough water to support that growth? It's remarkably similar to what the planners said. They thought they should be coordinated around stormwater management, flooding, planning for long-term adequate water supply, thinking about infrastructure and the age of infrastructure, as well as protecting environmental quality. So 2 different audiences, 2 different surveys. People are thinking very similarly. There is kind of a diversion across the country. So this is showing the results by different states. And you can see that different water issues matter more or less depending where you are in the U.S. So it's pretty intuitive again. The south arid states, in the southwest and the west, water supply is the top issue. Makes sense. And then you start seeing here in the flooding and stormwater issues are a little bit more evenly spread, but you kind of see this trend towards the northeast where flooding and stormwater are the top priorities that there should be coordination around. So again, you want to be context specific of what you're looking at by state and region. What is it that you're most important and need to manage for? But then there's some agreement across the board in that everyone thinks that managing for floods and storms is important, thinking about adequate water supply, and planning for future growth. Those seem to be, there's consensus across the country there. We asked them why they weren't working together. And again, this is all, I think, things that we would recognize and it makes sense. It's now how do we overcome those barriers? So the water resource managers said there's just simply a lack of time. There's too many other priorities to deal with. There's no mandates or incentives to work together. No one's forcing them. There's no law that requires land use planning to work with water managers. No one is responsible for coordinating. It's not a job you can get in the agencies. And there was some concern over losing organizational power, resources, or status. If you ever start working with public utilities, I have walked into political situations I had no idea about. It can be very contentious working with these agencies, and they're very protective. I had no idea about that, but it's true. We asked the planners. Some of the top barriers to collaboration was the separation of water agencies from planning agencies, so this actual kind of the siloing of different agencies. That is a major barrier. There's too many other issues that planners need to think about. There's fragmentation within water agencies. So I started this talk by illustrating how complex water management is. That fragmentation is challenging to work with. They cited a planner's lack of knowledge about water. I think this is true, and this would be one role that departments like these can kind of help solving this problem. So if you learn more about water as a planner, you're more likely to be able to act upon it, or as a designer, you can act upon it. And then they bumped into the same problems I have: water utility staff resistance or a lack of interest. So those were kind of the top barriers. There were some good open-ended responses from the Colorado survey that just reinforced these points. People said there was a lack of time and resources, and one person put, "It's not of central importance for any one person or department position. It would take a coordinated effort by multiple people whose time is already spread thin." They reported management silos. This was pretty interesting. So this is in Colorado. The number of water providers in one county. There are 49 water and sanitation districts in the county, and this does not include all the private water providers. It is a challenge to coordinate with all of them. You can imagine those planning processes. And then growth and development pressures. It seems as though revenue for land development can often overshadow patient planning. And I think that applies to a lot of different topics. So we asked them what we can do, and the water resource managers thought joint future scenario planning would be important, these kind of coordinated planning processes. Coordinating on land development permits. So before development occurs, let's get the water managers and the land use planners in the same room working together. Creating common or consistent data sets. I mentioned how difficult it is to get water consumption data. I think breaking down that barrier would help planners better plan for long-term growth and whether there's available water supplies. And then mandatory consistency between water and land use decisions. If there was a federal law or state laws that require coordination, coordination would occur. So in some states, they've already done this. Like Colorado requires cities of a certain size to incorporate water elements into their comprehensive plans. And as a result, the response in Colorado that said they were currently working well with water management agencies all had water elements in their comprehensive plans. So if you can cause some overlap between their required planning documents that both agencies have to do, you can start achieving some of this coordination. So to start wrapping it up, it is important to note that this isn't a total separation. I've done case studies, I've done interviews, I've done surveys. There is coordination occurring, and there's very good examples of it, but it's just about a third of the time. So it's not at the level that most practitioners would think is suitable. So there's more work to be done. Practitioners all see value in better integration. No one's ever said, this isn't important. Why are you even looking at this? Everyone knows it's important. It's just it's not happening. There's growing evidence to support the effectiveness of some strategies, but this would be what future research, this will be something I'm trying to work on in the next couple of years, is which of these coordination efforts are effective? Is including a water element in a comprehensive plan really going to improve water outcomes? Or is this just going to be one more process that doesn't necessarily result in improved outcomes? The barriers are clear, and what would be awesome would be if I could come back in a couple years and then report the next round of national surveys that there was better coordination. So it's interesting how this will be changing over the next couple years. So in conclusion, hopefully everyone takes away this one kind of big message from this talk, is that water management and urban planning should be better coordinated. And hopefully you see some of the reasons why. So thank you very much, and happy to have a conversation or answer any questions.